Let's talk about deleting a node in a linked list. Now, there's going to be two situations. Excuse me. One is the node is not the head, and the other is the node to be deleted is the head. So let's cover the first case first. The node to be deleted is not the head. Now, when we do delete nodes, we actually have to have a second pointer in play, and that pointer has to actually point to the previous node that we visited. So as we kind of go on and visit these nodes, here's one that was visited, then we visit the next one, but we still need to keep a finger on the previous one in order to do the repiping later after we delete. Then, if we were to advance this pointer, then we would also have to advance this pointer and so on. They'd have to keep working in conjunction with each other carefully to make sure that we can reference the necessary linked list nodes and not drop them. So the pointers that we'll use for this type of operation are just going to be current and previous. I'll use CURR and PREV. And declaring those is easy, just a statement like that will create a pointer called CURR or current, and we're telling it go ahead and point to head. So that's what we'll do here first. Current is going to be here, and then we're going to do the same thing for previous. We're going to just make it start by pointing at the head. Now, the first time through our traversal of this linked list, in order to find the correct node to delete, if it's the first time through, then we want to have an if statement right there to do one special operation for us. And that is, if it's the first time through, right now everything's pointing here to head. If it's the first time through, we only want to advance current to the next node and leave previous pointing here at the head. So we'll have a special case. Just remember that if we don't have to traverse, the first time through, when we do traverse, if it's the first time through, we've got to keep our finger pointed on previous, and we'll look at code for that. All right, so the first time through, let's suppose that it's this node right here, and it's got a value of 70 in it, and it's the 70 that we want to delete. So we will first, in a for loop, advance until we find it. We can either search by the value, or perhaps we've given the user a list of the nodes and they can just simply select an index number. So in this case, if they selected, I want to delete the third node, then we would just advance from 1 to 2, 2 to 3, and then we're there. So the next time we advance, we're actually going to advance the current pointer. And now this shows how current and previous will track with each other all along. And we have only advanced current the first time through this loop in order to get that separation and linking. So we do that again in order to advance one more. And we arrive at this configuration. We've also found the node to be deleted. So at this point, what we have to do is just replumb the previous pointer's next pointer from pointing to here to no longer point to there, but now to point over to here. Well, how do we do that? Well, we currently have a pointer on CURR, and its value here is already pointing to that next node. And that value is just part of CURR arrow next, and that gives us the exact node that we need. So here we would just set prev next to cur next. Set previous next to current next. Once that's done, this sort of frees the linked list memory allocation from the chain of the linked list. It's completely separate now. And once we have this configuration, we're disconnected, then we can go ahead and just delete that node with an instruction delete current. Since current is still pointing to that node, we've got our finger on it, we can reference it, and now we can delete it. And that's how we would do that. Here's a linked list, and let's say that that value happens to be the head that will end up being deleted. So no problems. All we have to do is have head point to this next node, and that will then free that node from the rest of the chain, and we can just delete it then. Well, right now this node is already pointing there. So to advance that, here's what we could do but should never do. We would never say head is going to be advanced to wherever head next is. And let me give you a moment to think about why this is bad. Well, it's bad because it would result in a memory leak. If we point head over to here now, then there is absolutely nothing pointing to that allocation there. And therefore, if we can't reference it, we can't use it. And it can't be reassigned for use because it's already got memory allocation. So this is a memory leak, and we want to avoid those like the plague. So we cannot do this approach here. There's got to be a better approach, and there is. It will require, though, using an extra pointer. So let's look at that. And here's that situation. We'll just create that pointer current, have current point to head. Once we do that, then we are free to re-plumb this head link straight to current next. So our code that we would do this, first we would just do a node pointer current, and then let's just assign that to wherever head currently is. Then we can assign head as current next. And all of our plumbing is complete now. That node is disconnected from the rest of the linked list, and now we can just simply delete current. And then to be a good steward of our pointers, since we're deleting current, we're not actually deleting the pointer to current. We're just deleting the memory allocation that current is pointing to. So we'll still have the current pointer available for our use, but we want to give it someplace specific to point because we just deleted the thing that it was pointing to. So now, if the processor puts something else in that memory location, well, then we have a pointer to that, and that makes no sense because that's not part of our code. So we want to just reassign current to the null pointer. And let's take a look at some code that's going to demonstrate this. And this code is available there in this week's demo code. And here's that demo code, the code blocks that deal with deleting a node. So here first, we just simply, as a feature of this particular demo here, I present a list of the nodes. Let me run it and I'll show you. This little output here is just a list of the nodes. It just traverses the list and returns the value and puts an index in front of it. And it allows the user then to pick the specific node that they want to delete. So in this case here, I'll say I want to delete node, how about 3 for where'd the rest of that go? Let me fix that real quick. There, let's try this again. Replit kick up there. So here's my linked list. And in this case, I just had the code randomly generate some values. And then we're asked, which node do you want to delete? Let me pick the 93 node to delete. And you can see here afterwards that, yep, that 93 is deleted. And now the old 14 is the new, I'm sorry, the old 4 is now the new 3. So how did we get there then? Well, had the user enter the integer 3. And that just means that we have to advance 2 times. We're already pointing to the first node. So we just have to go to 2 and then to 3. So this for loop right here in line 47 is going to do just that. However many they entered, -1. And look at the first clause of this if statement. That involves what I just mentioned, where if this is the very first time through this loop, we want to keep previous pointing to the head, and we only want to advance current. And then it's at that point that they're in lockstep and they'll continue to traverse together. So that's what that code does. And then here's the else clause, and that just, as you can see, will advance them both. All right, so at that point, what we have is current is pointing to the exact node that we're going to delete, and previous is pointing to the previous node. So it's just going to be a matter of freeing current from the chain by rerouting that one previous node's pointer, rerouting that around, and then we just delete it. So since at this point in our code, we have those 2 pointers pointing exactly where we need them, then we can just do the replumbing with resetting previous next, and wherever current next is, that's the next one in line. That's where we now want previous to point to. And then we'll delete current. And then, as I mentioned, we should probably put this in. To be a good citizen and steward of our pointers, then we would reassign current to the null pointer.